I want to also show you how to use the calculator to find the confidence interval here for matched pairs data. So remember that I already have found my, I'm going to go to Stat, Edit. I've already found my differences and I put them in L3. Of course, if you didn't have those numbers given to you, you could find them like I did. Or if they gave you just the differences, you could type those in. Or if they just gave you the numbers, D bar and such, you could use that too. Okay, so we're going to construct and interpret a 95% confidence interval. So let me type the formula up. 1 second, I'll be right back. There it is. Okay, now D bar and SD and N and all of that stuff, I can get all of that out of my calculator. Of course, if it was given in the problem, I mean, if they told me D bar is this or SD is this, then I could just type those in. But they didn't give it to me in this problem, so I'm going to go find it. Let me clear my key history here. So I go to Stat, go to Tests, and you want to choose number 8. Let me go down so you can see it. There it is, T interval. So I choose that. You can just press 8 as well. All right, now we have data for this one, and our data is in L3. If you had data in L1, you'd pick L1 or whatever. And then let me remember, is it 95? Yep, it's 95, so 0.95 for my confidence level. And I go down to calculate, and I press enter. And we wait. And there they are. And see, look, it's telling me my D bar. Let me bring this up. So D bar is 50.5625 plus or minus. The T thing I'll figure out in a second. And the SD is 52.501, and the square root of n is the square root of 32, right? Now the T, you get that from your T table. You can get it from the test. Hold on, let me go get a table out of the book. Oops, I also forgot that if you have a TI-84, it's actually available right here. See number 4, inverse T? So you can choose that and you can say, okay, the area in my alpha over 2, because this is 95%, alpha is 5%. Let me just make a note of that right here. Alpha is 0.05, so alpha over 2 would be equal to 0.025. So that's what you can type in here. You can say 0.025, comma, degrees of freedom, which in my case was, oh, I gotta go remind myself. Oh, there it is, 32. 32 take away 1, so 31. Oopsie, in the wrong thing. There it is, 31. Close parentheses, enter. And there you go. So it's negative 2.039. You don't have to worry about the negative positive thing. That gets taken care of by this symbol here in the formula. All right? And again, you could just go get that out of the table. You have a T table in your book or whatever. That's fine too. All right, so then I already found it again, but I'm going to do it again. Stat, tests, choose number 8. I should have written the answer down at the time, but that's all right. So let me go down here, calculate, press enter. And so my final result here would be 31.634, comma, 69.491. And there we go. I've shown the formula right here with the D bar, then the substitution, and then the final results. And I found my confidence interval. On a side note, I want to just chat about this last question before I move on to another tutorial, which is what value is not in there? And the answer is 0, right? This shows, or this is another way of showing that there is a significant difference between cell phone and non-cell phone users when driving, which is not any great shock to us because that's what we found back here with this hypothesis test. This showed us that we needed to reject the null hypothesis. There is sufficient evidence. Here, let me type that up. There we go. There is sufficient evidence to support the claim that there's a significant difference in the driving times for this task for cell phone and non-cell phone users. And that same significant difference is exactly why the confidence interval that you're finding doesn't have 0 in it. If they weren't statistically different, then they would have 0 in the middle of their interval.